An object with a mass of 2.5 kilograms hangs from a string that is attached to the ceiling at point P. A force F of magnitude 15 newtons acting horizontally from point Q on the string pulls the string to the left as shown in the diagram. The forces acting at point Q are in equilibrium. Write down a conclusion that can be made from the underlined statement above. So they want to know, what does it mean if the forces are in equilibrium? It basically means that the net force is zero. Net force is equal to zero. That means we can draw a closed triangle of forces. So question 2.2, calculate the magnitude of the tension in the string. So if we have to draw our free body diagram, we'll find that we're going to have a force of gravity that's pulling down, like so. Actually, let's put it here. So force of gravity is going to go straight down. So that force is done. Then you have a rope that's pulling to the left. So that's also a force applied, 50 newtons. And then we have this force, the tension force, that is going this way. So you can see we have a closed triangle of forces, head to tail diagram. This is going to be 90 degrees, and we want to know what is this angle right here. We don't know that angle, but we want to know the tension. So we know the force applied. Force applied is 15 newtons. We can work out the gravity. Remember, force of gravity is equal to mass times acceleration, or mass times gravity. The mass is 2.5. The gravity is 9.8. So if you want to work out what tension is, all you need to do is use Pythagoras. Okay, so we'll use Pythagoras here. We'll say that T is equal to the square root of 50 squared plus, now let's do this last bit. So 2.5 times 9.8, that is 24.5. So 24.5 squared. And if you put that in your calculator, you should get, so 50 squared plus 24.5 squared, you get an answer of 55.68 newtons. Question 3. A student conducts an experiment to investigate the relationship between the resultant force of an object and acceleration. The experiment is set up using a trolley on an inclined runway and a ticker timer that makes 50 dots every second. So 50 dots every second is a measure of the frequency. So frequency is 50 hertz. So they want to know, calculate the period of the ticker timer. So period, capital T, is equal to 1 over frequency. The frequency is 50, so 1 over 50 is 0.02 seconds. Next question, when the trolley is released from the runway, it moves down the slope and the following ticker tape is produced. Briefly explain why the dots on the tape are initially very close together. So it's because the object is accelerating from rest. So the object accelerates from rest. So you can think of it like this. Imagine there is a road, and on that road there is a truck or some vehicle, and that truck has an oil leak. Now if the truck is at a stop street, right, and it is currently stopped there, the oil is going to drip down. Now when the robot, or when the traffic light turns green, the truck is then going to accelerate that way. You'll notice that if you look at the dots on the ground, the dots are initially going to be close together because it's not moving that fast. But as it accelerates, the dots are going to go further and further apart. So to answer the question again, why are the dots close together? The dots are close together because the object is accelerating from rest. Question 3.3. Oh, the information they give us here is the slope of the runway is adjusted so that the dots are evenly spaced. So what does that mean if the dots are evenly spaced? It means that it's now moving at a constant velocity. It's not accelerating, it's not decelerating. So was the ramp angle increased or decreased? The ramp angle was increased. No, the angle was decreased. It's now gone flat. So it was like this, so it's speeding down. Now it's flat, so the angle decreased. Tricky question. It decreased. What is the magnitude of the resultant force now acting on the trolley? So the resultant force, in other words, F net, is going to equal 0. And why is it equal 0? Because F net is equal to ma. And since the dots are evenly spaced, it means that it's moving at a constant velocity. Constant velocity means acceleration is 0. If acceleration is 0, F net is 0. Now 3.5, the trolley is now accelerated by first using one rubber band, then 2 rubber bands, and finally 3 rubber bands. The rubber bands are stretched to the same extent each time. The 3 sets of results are plotted on a velocity time graph shown below. Okay, 3.5.1, which graph represents the results when 3 rubber bands were used? Choose from A or B, give a reason for your answer. So I'm going to choose A here. Why am I going to choose A? Because A has a greater slope, right? And a greater slope means a greater acceleration, right? Why would there be a greater acceleration? Because there would be a greater F net. Or you could say the other way around. Greater F net because there's now much more force because there's 3 rubber bands. So question 3.5.2, sketch a graph to show the relationship between the acceleration of a trolley and the force in rubber band units acting on the trolley. So they want to know basically what is the relationship here. So we want to look at acceleration on our y-axis and force on our x-axis. So, or rubber band force. And it's a directly proportional relationship because if you increase the force on the rubber band, the acceleration is going to be greater. And so it should go through it should follow that shape, going through the origin where no force means no acceleration.